Hello guys, welcome to today's our lesson. We are learning about linearizing for y equals to a e power of kx. Okay, so this part is the same as the last lesson. Like we can just logarithm on both sides. So here, for example, like y equals to a times e power of kx, you can first logarithm on two sides. So it will become into ln y equals to ln a e power of kx. Okay. So then you can just written down, here is ln y, and here it equals to ln a plus k times ln e power x, right? And we also know for the logarithm is a inverse function for the exponential function. So it will become into ln a plus the kx, right? Okay, that is a function here. So also you can just written down, like you just consider ln y as a capital letter y, and here is a capital letter x, so we can just consider y equals to ln y and x equals to smaller x, okay? That is for logarithm function here. Okay, so for example, like if y equals to a times e power of kx, we can logarithm on both sides, so it becomes into ln y equals to ln a e power of kx, okay? So that will becomes into, here is for ln y equals to ln a plus ln e kx, right? So here you can just simplify it as kx plus ln a, right? So you can just consider here as capital letter x, here ln y is capital letter y. So just you can just calculating for the k and the c, right? You can just consider like y equals to mx plus c, and then you can calculate. Okay, that is for this example. And here's the solution. You can just using the y2 minus y1, the differences in y over differences in the x to calculate the gradient here. It's not very difficult, right? Okay, so also you can just find what is the final answer. You can find c is ln a equals to 2.085. Then you can use your calculator to calculate for the a's value here is equals to e power of 2.085, and exactly the a approximately equals to 8.04. Okay, so that means y's value equals to 8.04 times e power of 0.75x. Okay. Okay, so here's a quick practice for you. So if you want to try yourself, you can just pause the video and then do it on yourself. But if you want to follow with me, you can keep on going. Okay, so maybe let's move to the first problem. So here is that y equals to a e power of kx, right? So if you want to calculate the ln y and against x, so you can just ln on both sides. That is ln y equals to ln a e power of kx. So it will become into ln y equals to ln a plus kx, right? But then you can let, this is y, this is c, this is k, this is x, right? So it's y equals to kx plus c. So k is a gradient, right? So you can just using the y differences over x differences to calculate the gradient. So here is for k equals to y2 minus y1 over x2 minus x1, right? So just you can put in the value into it. So if you have y2 minus y1, you can set this value is for like 1.81 minus 1.39, right? And x2 minus x1, that means x2 here is for 0.6 and x1 is 1.4. So just using 0.6 minus 1.4, then you can calculate it, right? Okay, so then you can set like 1.81 minus 1.39 equals to 0. I guess is for 42, right? Divided by negative 0.8, okay? So the value here is for 21 over 40, right? Negative 21 over 40. So let me use the calculator, okay? So here is for 21 over 40. So the answer is about negative 0.525, right? So we can say k is a negative value. And after that, we can calculating the value c, right? So we can put into this point. So that is what 1.81 equals to negative 0.525 times 0.6 and then plus c. So the c value here equals to 1.81 plus 0.6 times 0.525. Okay, so then you can calculate the exact value here. So 0.525 times 0.6 plus 1.81 equals to 2.125. Okay, that means ln a equals to 2.125. So if you want to calculate exactly what a's value, you can set a equals to e power of 2.125, right? So you can just use a calculator, you can type into like e power of, okay, so here is e power of 2.125. You can calculate it is around 8.37. Okay, so the value y equals to 8.37 times e power of kx, right? So here k equals to negative 0.525x. So you can just written that this way. Okay, so that is the value of a and k. And also for question 2, like here, we said ln y equals to 2.4 minus 0.7x, you can first just make an exponential on both sides. So it becomes into y equals to exponential 2.5 minus 0.7x, and then it is for e power of 2.5 times e power of negative 0.7x. So this value can be considered as k is negative 0.7, right? So also you have to calculate it for e power of 2.4. The value is around 11.20. Okay, so 11.20. So we can say a is around 11. Okay. So that's for this our lesson. I hope you can really understanding for the function changing here. So it's not very difficult, right? Okay. So that's for this our lesson. See you next time. Bye.